Hello everyone, welcome to Knowledge India once again. In today's session, we have Tim with us. Tim works with AWS as a senior solutions architect. He has been programming for 20 years plus, right? And he has worked in the past with a couple of other organizations where he was a customer of AWS for 10 plus years. He has used ECS at a really good scale. And in today's session, Tim is gonna show us a hands-on demo around AWS Copilot. So we will try and understand that why Copilot service came into picture really and what type of problem it solves. In this particular session, we are going to have a lot of discussion among us, and in addition to that, we'll have good amount of demonstration. We have got a lot of demos today, so I'll request you to watch it end to end, and if you want to go ahead and do it along with, then nothing like that. Go ahead and please do it as well. So with that, we would like to get started. Welcome, Tim. How are you doing?
Good, thank you. Nice to hear on your channel.
Hey, thanks a lot. Thanks a lot for taking time. So as we discussed that we will talk about the service Copilot and we'll try and understand that, why it is really useful. But I think it would be good if you can give some background that how did you start with the whole, container journey, let's say in terms of AWS, if you could give some background around that.
Yeah, it's a good question. Many years ago, I actually started on the very first days of when ECS was first released. And we call that now running ECS on EC2, but back then we just called it ECS. So I actually migrated a moderately large environment from private cloud onto an ECS environment. And in that process, I learned a lot about running Docker containers at scale. And I also had needed to create a lot of tooling and make a lot of decisions for how to deploy my environment. So my cloud environment across the different services, the different cluster, the different applications. There was a lot of decisions that needed to be made in order to run at a really, really high scale with security and the good practices of cloud deployments, infrastructure as code, and so on. So it taught me a lot. And in that process, that's how I came to really respect the value of what Copilot is. Back in the days when I was first releasing onto ECS, I needed to make a lot of tooling. And now I think back on it, the ECS team has come together and they've created an open source solution which does a really, really solid job of all the tooling that I would have ideally made to release my application onto ECS.
So Tim, sorry to interrupt. So when you are saying tooling, could you elaborate a bit more that what all was included in that tooling which you were doing manually earlier?
Yes, sure. So to deploy an application onto onto ECS, although I can click around in the console to deploy my changes, it's generally, if I'm deploying a typical service onto ECS, there might be quite a number of things that I'll be deploying. I actually need to consider where my secrets live. What are my test environments? What VPCs I'm running in? What ports should be open for each of my applications? How should my applications talk to each other? And when I want to release a change to my application, what's the process for safely deploying that change with automation and a strong level of automated testing? So in order to maintain all of the considerations of what's needed to support a production application, to ensure that I'm tracking my secrets securely, and to make sure that I'm promoting my changes without needing to take the old approach of ClickOps, I needed a way of making my environment fully, following the modern practices of DevOps, so CI/CD, infrastructure as code. Now, I could deploy all of my changes as CloudFormation, But certainly back in those days, CloudFormation wasn't as mature as it is now. But that's also a lot of very, very, I'd say, verbose JSON documents for my team to be working on.
Mm.
And in order for developers to be productive on a modern cloud environment, something that's, I'd say, a little bit more prescriptive can be useful. If I take a delivery team and I ask them to produce let's say a 800-line CloudFormation document in order to describe their service, that team is going to be slowed down a bit. And this is where the tooling develops. And typically we see these days, we'll have a platform team. A company will have a platform team who will develop this tooling for the developers to use in order to be productive in their organization. As a platform team lead, this tooling didn't exist back in 2014, 2015. As a result, I needed to develop this tooling.
Okay, right. So say, even if it was possible, let's say to do via CloudFormation to a certain extent, it still involved writing a lot of code and doing that. And basically anybody who is consuming ECS, it was their responsibility in a way to write it. Like, as you were consumer at that time of ECS service, so you had to kind of develop that whole thing, right? Which was an extra effort at that time.
That's right.
Okay.
It's doable, but I wouldn't say it's ideal for a delivery team who's really focused on releasing changes for their customers.
Right. Right. And of course, we are talking about the time when it was all EC2 based ECS thing, which was the default option. And now we have Fargate. And Fargate, I'm like, it's true that Fargate takes away a lot of headache from consumers' plate, because you don't have to worry about maintaining VMs or EC2 instances. But still, I think all the other things, as you were saying, things like the networking part or the secrets part or the load balancing part, that is still there for us to decide, isn't it?
That's absolutely right. It's actually not too painful in 2022 to develop on Fargate using CloudFormation. The service has come a long way, and even ClickOps now is quite a painless way of releasing applications. But where it falls down is when you really need to scale, when the teams get quite large, and when you start to have the need to provision many different environments and to promote your code across regions, across environments, and with always scaling your team. So the team gets larger and the deployment gets larger and the complexity of your infrastructure gets larger. So this is where the tooling is really needed to streamline that development process. Okay.
And that's where Copilot can help, isn't it?
Absolutely. So what the Copilot team have done, they've taken, I would say, opinionated defaults for how to operate an ECS cluster. And so the Copilot team is developed actually from the ECS team, the team that works on ECS. And they've taken a very prescriptive approach to the tool. The tool makes a lot of decisions with security by default, provisioning test environments by default with pipelines, CI/CD, all of these concepts built in. And it vastly reduces the number of decisions which I would need to make as a platform lead.
Okay. So it's like, yeah, I mean, when we look at it from an application team's perspective, it is not just about creating the ECS cluster. Of course, around ECS cluster, there are a lot of other things required for your whole application to work, and that too, when it comes to having multiple environments for your application, there are so many things, additional resources which need to be created. And then you also need to know about or decide upon the correct attribute values for all those resources. Copilot kind of makes this easy for you.
Absolutely.
Is that okay, that's a summary. Okay, good. Are we seeing some sort of demo to understand this, Tim, or how's it?
what we'll do, let's have a look at,
Mhm.
let's deploy a service using Fargate.
Mhm.
So this is we'll do it through ClickOps to make it quite clear. But what we're going to do is we're going to deploy a service using Fargate,
Mhm.
and we'll see all of the steps involved with that.
Mhm.
And then we'll do the same thing with Copilot.
Okay, yeah, makes sense. That would be a good comparison actually between the two approaches. Yeah.
Absolutely. So let's get started. So what we're going to do, we're going to create a cluster for Fargate. And I'd like to just introduce a few quick concepts to start with.
Mhm.
So when we create a cluster with Fargate, there's a few core concepts that we have. The first concept that we have is the grouping concept of the cluster. And what we're going to do, we're going to create a cluster where we don't need to think about the instances that we're running. So let's call our cluster simple demo 1. We're going to use the default VPC that we already have created on this AWS account.
Hmm.
And the cluster can really be thought of as a grouping concept for our application's resources. Now, underneath the cluster, to actually run the things that we want to run these as a service. And a service contains a set of tasks.
Hmm.
And it's those tasks where our code actually runs. So let's imagine that we have a web server that's running 3 instances of an application that's just serving up web requests. We will have one service, and within that, we'll have 3 tasks.
Okay.
But we also need to know what those tasks are going to run. Are they going to run a Node.js web server? Are they going to run something on Nginx? What should the code be? For that, we have a task definition. So let's get started. And I've just pulled up a simple Hello World Docker image. Just searched on the public ECR gallery. So what I'm going to do is I'm just going to take this simple Hello World service, and we're going to deploy that with Fargate. So let's get started. So the first thing I need to do now, I need to create a service. So let's do this. In fact, before we even need to do that, we know that our application is going to be internet facing. So what I'm actually going to need to do first is to create a load balancer. And to create a load balancer, I need something the load balancer is going to point to. So don't worry too much about this one. But first, what I'm going to need to do is to create a target group. This is the concept that's going to allow the requests from the customer to be routed to our ECS cluster. So I'm just going to create a simple target group. I'm going to serve on port 80, which is a typical web port. And I will just point to IP addresses. So when we point a load balancer and target group to an ECS cluster, we need to use the IP addresses target type. So I'll go and I'll create this one. So let's create our target. We don't have any targets for it yet, but we'll get to those in a second. Now, the next thing I'm going to do is I'm going to create a load balancer, an application load balancer, because we're just serving HTTP requests here. So demo and this will be an internet-facing load balancer. And I'll just run this in all of my availability zones. And I'll select the target group that I've just created. Okay, so we've got a target group and we've got a load balancer. Now we're going to create the service that's going to serve our application. Okay. I've actually already created a task definition. I don't want to reuse that one. I'm going to create a new task definition as well. And the task definition is just that's going to define what our service should run. So let me get this one, demo task definition. Now we don't need any particular IAM role for this particular demo. we do want to run this one on Linux. And I'll give it, say, 1 gig of RAM and half a CPU. Let's give our container name demo application 1. And I'll take the repository, just the Docker image for this Hello World application. Now give it a, now I know that this application here happens to serve on port 3000. So what I'll do, I'm just going to expose this to port 3000. And I'll take all the defaults here. Okay, so we've got our task definition. Let's get back and create our cluster. Sorry, create our service. Now what I'm going to do rolling update for this one. I could also do blue-green to allow for very smooth release process. But for this, I'll just take the defaults. Now I'm just going to use the default subnets that are on my default VPC. And I'm in US West 2, so I've got 4 of these. Okay. I'd like to use the load balancer that I created earlier. Target group, I can use the existing target group that I've do not select that. Okay, so I'm taking pretty much the defaults. I'm listening on port 80 here.
And the container port is 3000.
That's right. So let's create this service. So what's happening now, Fargate is actually provisioning the task that we've set up. It's actually pulling down this Docker image that we've found here, this Hello World Docker image, and it's provisioning it into the cluster. And in not too long, what we're going to see a task being created, and I could run as many tasks of these as I want. I could run 100 of these if I have a really high load. And within this task, what we can do is we can actually make requests, and we can use that as a web server, and when we were setting this up, we even set this up to have a public IP, just for the purposes of showing how this works. But we also have a load balancer, and that's the key thing. We don't want to talk to the individual tasks. We wanted our customers to communicate instead with the load balancer that's attached to this. So let's have a look at that load balancer again. So we have a DNS entry on that load balancer, and we can use this load balancer to make requests, which will ultimately be routed to our cluster, and they'll be routed to the healthy tasks that are running on that cluster. And we can see now here that we've got one of these tasks running.
Yeah.
So let's just have a quick look at this now. We have the task. Now, can we see this task running? So we're going directly to the task. This is just for you could say debugging purposes. Let's have a look at what this task is doing. I haven't opened up any security groups, so I'm just going to assume that this should not quite be accessible just yet. Yep, so this one's not reachable. I'm just going to quickly modify the security group of this so we can access the individual tasks as well, so we can see what's going on.
Yeah.
It's on the task definition. So let's just modify our inbound rules. We'll just add so we can access this on 3000.
Yeah, that's.
talk to our task here. Okay, so we can see here that we can actually use this task as a web server at this stage. So let's just go back into that again. And so the Hello World application that was pulled down, although we can hit this directly through the task, it's much more common that we would do this through the load balancer. Let's access this through the load balancer. And once again, we'll likely need to check the security group of this one. Oh, there we go. This is all sorted. So the advantage of going through the load balancer here, if we want to have more tasks running, we can actually spin this service up so we can allocate more resources to the application. So this was relatively painless, I would say. It was quite easy to get this running. There was still quite a few decisions I needed to make there. So this is where Copilot comes in, and I'd like to just do the same action on Copilot. But just before I do that, do you have any questions about this whole process?
No, I think it is clear, but if we just try to summarize this, even like though we have just taken a very simple example, if we try to summarize the decision points, that would be good, so that when we go to Copilot, it would be a good comparison to understand. Like, for example, we had to create load balancer separately. We had to take care of security groups separately. What else? We chose to use the existing VPC. But yeah, that's the decision which we had to make. What other things we probably decided? If you can just touch upon that, that would be good.
Yeah, sure. So we did need to choose quite a few things here around. We needed to choose the CPU memory allocation. Let me see, task definition, clusters. Actually, there's not that many decisions we needed to make. The complexity here comes if I had, let's say, a test environment and a production environment, it's very difficult for me to track all of those decisions. So anytime I make those decisions, the action I take can be repeated. Now, the example we've given is quite simple. So it wasn't too many decisions to make. If we were tracking secrets in this application, so let's imagine that this application had some sort of a token that it needed to communicate with a third-party web service, that would start to introduce one more decision point.
Right. Yep.
Similarly, if I needed to give this particular task an IAM role, let's say we needed this task given permission to talk to a particular DynamoDB table, that would be another decision point I would need to make. And I would need to create the role that allows the task to communicate with that DynamoDB table. And I would need to set that on each service for each environment that I deploy this to.
Yeah, so that means, of course, if you are looking at, let's say, 2 environments, that means 2 different IAM roles, and if it just increases with the number of environments we actually need, right? Although that's a different thing that many of the times we see that people do not care about creating roles with proper fine-grained permissions, which is a bad thing to do. Of course,
Yes.
We need to have very properly roles defined with the least privilege principle, of course. So yeah, at least one role per environment, that's what it would be.
Yeah, absolutely. And when we're doing manual tasks in this ClickOps environment, as we call it, we often find that we get lazy and we do create these roles that have too many permissions attached to them, rather than following the principle of least, what is it called? The
least privilege.
Least privilege, that's the one.
Yeah, right.
Cool. Maybe what we can replicate what we just did now, and rather than clicking around in the console, we can just do this using Copilot.
Okay.
So what I'm going to do, I'm even going to install Copilot here on my local environment. So I've just gone to the Copilot webpage. I've just gone to the Getting Started page, and I'm going to install Copilot here. So I'm running on Linux. I'm actually running on WSL2, so Linux on Windows. But let's first start by installing Copilot here. Just copy pasting from the install Copilot on the Copilot website. And I'm on sudo, so I just need to give it my password. Okay, so Copilot has just been downloaded and installed. It's a Golang binary, so it's just a single binary that needs to be downloaded. And the default process is just to download that into my path where I can run it straight away.
Okay.
So what I'd like to do, I'd like to set up a working directory for where I'm going to start my Copilot application. So let's do demo application 2, we'll call it. Demo application 2. Okay. So Copilot gives us the ability to take all of the steps that I've just done, but to do this very, very quickly from the CLI, but not just from the CLI. Copilot also creates a manifest file which describes all of the actions it's going to take. And typically we would check this manifest file into GitHub. But let's get started and see how Copilot works to begin. So what we'd like to do, we'd like to initialize a new Copilot application. So and typically we'll start with Copilot init. So do I want to use one of my existing applications? And this means one of the applications that we've already set up here. I don't want to. I'm actually going to pull down. I'm going to pull down the Docker image that we were using earlier. So let's start by creating the application. Now, Copilot has a grouping concept of an application which contains both environments and services. And later I'll share a quick diagram of what that looks like. But let's get started. We're going to call our application demo application 2. And for what we're running, we'd like to run a load balanced web service.
Oh, so here, okay, this is really good. It gives you the, those typical architecture which you might go ahead and implement. Okay, so probably based on this, it would figure out the different resources which it should create.
Absolutely. So
okay,
I could run an application which is a background task. I could run a load balanced web service, or I could run a scheduled job that runs on a cron job. So let's say a service that runs every hour to do some particular batch operation. Yeah, Copilot helps us to choose. It helps us to guide based on our use case what we need to deploy for each of these cases. So let's start by doing a load balanced web service, as we've done in our previous ClickOps demo. Now, the application can have a number of services within it. I might have, for example, an application that's made up of multiple microservices, some worker services, and some scheduled tasks. So the application is the grouping concept, and the service is a particular piece of code that runs in that application. So we'll call this demo service 2. And I want to use an existing image. Often, if we're doing this for code that we've written, we will track the Docker file within the code repository of the code that we're running. But for the demo we're doing here, we're taking a public hello world image and we're deploying this one. So let's use an existing image. Oopsie. I'll just copy this one and paste this in here. So we know that our container listens on port 3000. So we'll tell Copilot to use port 3000 for this Docker file. Now, Copilot is deploying all of the changes that Copilot deploys here are deployed using infrastructure as code.
Okay.
What that means is any changes we make to our application or to our service are performed in a way that's easy for us to track and easy for us to, let's say, roll back or to replicate across environments.
So Tim, while this is happening, we should be able to go and see this in our CloudFormation tab probably, right?
Absolutely. So let's go and have a look. So I've just got my CloudFormation tab open here. And what we can see here that Copilot is provisioning to start with the dependencies that we need to manage the overall application. Now, there's a few more, there'll be a few more stacks here. The first thing we have here is what we need to administer the application. But what we're going to get into now is a test environment and the actual deployment of the service. So just to break this into smaller chunks, I'm actually not going to deploy the test environment just yet. I've just created the grouping concept for my application to start with, and I've pointed it to the Docker file that we're using. We do need to create a test environment. So let's do Copilot environment init -m test to create a test environment for our application. We can also create a production environment as well, but we'll start with a test environment.
Okay.
Now it's just asking which of the profiles I want to use on my local computer. So I'm using the Timothy Downs profile. And I'd like to import existing resources that I have. I could use this to create a VPC, to create all of the things that are needed. But what I'd like to do in this case is to reuse the resources that I have.
So if I'm interrupt, 1 second, Tim. So the profile which you selected, that profile has to do with like your credentials to interact with AWS. Is that the thing?
Yes,
okay.
That's my local credentials. That doesn't have anything to do with Copilot. That's just the local.
Basically, the profile which you set up in AWS CLI. Is that right?
That's right.
Okay, cool.
So it's picking the VPC that I have available here. And then I can pick the subnets that I'd like to deploy this into. Now the default VPC only contains public subnets. And it's generally not recommended to run a production workload without private subnets because it makes it a little bit more difficult to use internal load balancers, which are often needed. It still allows me to do it.
Yeah, but the good thing here was, I think the good thing here was that it showed us the different VPCs. Currently, I think in your account, there is only one. But if we have created a custom VPC, it will show that as well. And we can very well just select that and then respective subnets.
Absolutely. And typically when I would use this for myself, I would actually allow it to create everything in the first run, and I'd allow it to create all of the VPCs rather than reusing the default one. Because typically when I create an application, I do want to have a segregated VPC from the rest of my resources in that account.
Okay. And if we do that, the VPC which gets created by the Copilot, let's say with whatever default setting Copilot has, that VPC will have public and private subnets both in at least 2 availability zones or 3.
Yes, that's right.
Yeah. Okay. Right. Sure.
Okay, so what's happening now, it's creating the next stage of what we need here, which is another CloudFormation stack. So this is the CloudFormation that we need in order to support our test environment.
Can we click on the stack and look at the resources as well? So that will give more clarity that what all resources are getting created inside.
Absolutely. So for now, we're creating the ECR repository for this particular environment. We've got the S3 buckets for the pipelining of our releases and KMS key. So let's see, I would imagine that we'll probably have, oh no, that's it. I think there might be another stack coming up then. Let's have a look.
Probably it should move. Okay. Infrastructure changes for this. Maybe now it will come up. Let's see.
Yep. So now it just needs to provision the IAM roles to actually perform the changes to this environment and to manage the resources that Copilot will be managing in that environment. So Copilot is not just for the pipeline and not just for the code. Copilot can also manage some of the data tier in your environments. You can also provision custom CloudFormation in each of your environments. And to support this, it's creating the necessary IAM roles for that environment. Typically, we'll just need to do this when we're actually creating our environments. We won't usually need to do this as we release our code each time. And what we'll do, we'll have a look at the file that is being produced for this environment. So let's have a look at the manifest that's being created, which is describing as code what this infrastructure looks like.
Right.
So what we can see here, we've got our test environment. And here is where we can specify any particular bits of information about this environment. In this case, the only decision points were the subnets and the VPC. But let's have a look at the other files we have in the Copilot has created. We can see that we've got the test environment, but let's also have a look at the service that we're deploying here. And in this case, this is describing the application that we're going to run. If you recall, when we ran the first step, we did indicate that we're using this image on port 3000, and it's giving us a default for CPU and memory, but we can modify the manifest file and we can change these values to be anything that we want. Typically, this is where we would indicate what secrets should be used for our applications, and for example, what environment variables or log levels the application might need. So let's continue. Let's actually deploy the environment. And then we'll have a look at what's being created in CloudFormation.
So if I understand correctly, sorry, Tim, if I understand correctly, till the previous step, actually nothing got provisioned in the within the ECS service. Only the IAM related resources got created, or some pipeline, etc., got created. But ECS is gonna get created only now when you have run this deploy command, correct?
That's right. So now when I'm doing my first deployment, this is when we start to see the actual ECS environment be created. And we can see here that a cluster is being created, along with all of the other resources that are needed for this application.
Like security group and IAM role and all of that.
Absolutely. And also the load balancer.
Yeah. Load balancer, where it is, it should be there somewhere. Maybe it is yet to be created. Yeah. And we should be able to verify it, because now like you had changed the memory to be 1024. So whatever is getting created in that, it should be 1024 instead of that default 512 thing. Right.
Yeah, let's have a look at what we can find here. So it hasn't yet created the task definition.
Yeah.
It's going to do that for that particular environment, but let's have a look at our cluster to start with. So this is the one we created earlier with the ClickOps. And this is the cluster that's just in the process of being provisioned now.
Correct.
So we haven't got our task in here just yet, but we'd expect that to come up quite soon. So this one is an ECS. Sorry, this, yes, okay. We do need to actually deploy the service to that environment, not just to deploy the environment, we also now need to deploy the service. So let's do Copilot service deploy minus M.
Copilot in the start.
Yes. So this is where I'm expecting for the rest of the resources to be created. And typically this deployment command might be what I'll do to deploy my code to a particular environment when a change is made. So this one Although now it's creating all of these resources, each time I deploy my code, it won't need to do this. It will only need to provision all of these fundamental resources on the first run.
Right.
And we can see here that it's there's quite a number of things which are getting provisioned in this step. In particular, the load balancer and the target group.
Correct.
And these are all being stitched together by Copilot in the background without us needing to think about any IAM roles, or without us needing to think about how the load balancer and the service work together. So let's have a look at this.
So here, before we go from the screen, I just wanted to ask one. So like the last line we are seeing here, an IAM role to control permissions for the containers in your task. I'm guessing that it would probably be creating an IAM role which will get assigned to the tasks so that it can interact with any other AWS service.
That's right. Let's have a look at that though. Let's have a look at that resource in CloudFormation.
Yeah.
So let's go to our stack here. So we can see here that we've got the environment for the test environment for our application. And now what it's creating the environment for that particular service, for that particular application. So let's find the IAM role that we're working with here. I believe it's the task role here.
Yeah.
So this is the role that the tasks running within this service in this environment will be given. And if these tasks need to interact, let's say, with DynamoDB, this is where the task will be found.
So currently it has given like the two default policies are attached in this particular IAM role, and yeah, which is more like pretty standard. But if we want to change, we should be like, I think you are saying that if we want to update something later on, we realize as we are moving ahead in our application development journey that we want our task to interact with more AWS services, we should be able to easily modify this IAM role definition and then deploy that. Okay, we'll look at it as we move.
Absolutely. And if we're interacting with the resources which are being created by Copilot, then we don't even need to think of managing that. This will all be stitched together by Copilot.
See, yeah, that's the benefit. So that means if as part of Copilot itself, we are, let's say, provisioning a database as well, then and if it is probably DynamoDB, then the permission related to that DynamoDB table will get added in the IAM role automatically. Is that correct?
Yes, that's correct.
Okay, good stuff.
So let's have a look at what's being created here. So we've got our load balancer in the environment here. And I believe we should have our task definition coming up soon. So let's have a look at our cluster. Yeah, we've got our task definition up now. And we can see here that this has the changes that we've written into that manifest file.
Correct.
And this makes the configuration of our services considerably simpler for a developer. For a developer to manage one of these tasks, they can, if they need to provision, let's say, more compute for a particular task, they can easily modify this using a much simpler interface than, let's say, a very powerful but verbose CloudFormation template for their particular application. So what this service does, what Copilot as a tool does, I would say it really empowers developers to contribute to the architecture of their application rather than just writing the code that runs their application.
Correct. So like any property related to basically the properties or attributes related to the task, that also they can control, and a lot of IAM permission thing, of course, gets automatically written, and if they want to modify it, they can do it in an easier manner.
Absolutely, in a much simpler manner, with a lot of the decisions made for them, but with still the ability to typically override those decisions when needed. So we can see here that we've had our service provisioned here, and if we find our load balancer, we should be able to. In fact, we don't even need to find our load balancer. Copilot is actually, when it completes the release, it's actually telling us what the URL of our load balancer is. Yeah. And we can visit that URL and hit our service.
Right.
So that's the process of doing the ClickOps steps we did earlier. But instead of clicking through the console, we're running this through Copilot CLI. We'll typically just need to do this once, but the real advantage here is that now we have a manifest file that's repeatable. If we
that's where the real power now comes in, right?
Absolutely. If I want to create a new environment, it's very easy for me to do this now. That's the kind of the difference there you can see of the ClickOps approach for Fargate as opposed to using Copilot.
So Tim, if it can we just quickly try and use the manifest file and create a new environment, or maybe let's say the one which we created, that was the test environment. That's what we'll assume. And if we want to create a similar environment, which will be our production, but we want to change just a couple of properties or maybe one property, if you can quickly just show that part, that would kind of convey the message that how it makes the whole thing easy.
Absolutely. So let's deploy a production environment for this one. It's a great idea.
Yeah, maybe we'll just edit something in the manifest file if that is okay. Maybe
we will need to create a new environment first.
Yeah. Sorry. Mm-hmm.
So what we'll do is we'll see how the manifest files change here, and we could copy paste the environment into that structure, but this is a simplified way of creating that second manifest file, and then we can look at how the different environments are structured by Copilot. Then keep in mind, I could use a different profile for different environments. So what I could do here is I could actually provision a new VPC for this one. Let's do this. We'll provision a new VPC for our production environment, because certainly it might be nicer to keep our test and our production environment segregated from each other. So let's create a new VPC for this environment. And this might take a little bit longer just because of the resources it needs to create. And while it's doing this, let's have a look at the second manifest file and see some of the differences here. Okay. It's a very simple manifest file. We'll allow this to run first, and we'll get the VPC up, and then we'll have a look at the resources that have been created here. Let's have a look. So we don't have our VPC created just yet. I think we need to deploy the environment to have the actual network resources provisioned, and then we'll have a look at what comes up in our manifest files here. So you were absolutely right. There are 2 private and 2 public subnets created by default. And this is just the default settings for a new VPC here. Let's have a look at some of these resources that are coming up when Copilot is managing the new VPC here.
So the whole VPC related resources also we can see now. Yeah.
Just down to the service discovery and the VPC gateway attachment for the internet gateway. Looking good.
Yeah.
Okay, so now we've got our new production environment, and let's deploy the service into this environment. And once we've deployed the service into our environment, maybe what we can do is we can start to, let's say, give the service in production a little bit more CPU and maybe some more tasks than we have in our test environment.
Right.
But using the manifest rather than using ClickOps. It's still just updating the listener. As soon as the listener is created, it can then create the service, which it's just doing now. And what's happening now, the actual deployment of the task is in progress.
Right. It is in the pending state and it should. Yes.
Yep. So this service should be just starting now. And let's just go into our cluster here just to have a look. So we can see here that our cluster for test and production are segregated. They're running separate clusters.
Yep.
And we've got our task active now in the production cluster. So this service is just about to be, oh no, it's desired one running 0. So it's just coming up, just in the pending state still. And we can always jump into the logs if we ever need to debug the service, although it hasn't produced any logs just yet. Okay, service is now running, so this should be picked up shortly.
Right.
Okay, we now have our service up. So we have a production environment running within its own newly created VPC. So let's go to the next step. Let's see if we can override the settings of the service as it runs in a production environment. This is actually a good time just to reiterate the concept of environment, application, and service. Just if we remember here, we've got the grouping concept of an application. So let's say we have a particular, let's say a blog application. The blog will have a test environment, it'll have a prod environment. And for each of those environments, there might be a number of things that environment needs to do, and maybe a number of different microservices. So this is the bird's eye view of the different architectural concepts that Copilot has.
Yeah, and in the demo, you first created one application, which was the first step in the Copilot demo, which you did. And then you actually created 2 environments. First one was test and then prod.
Yes, that's right.
Okay.
So to override the values for a particular environment, I actually go into the service manifest file. And then I have a bit of an example here for overriding this for, let's say, the production environment. Perhaps in production, I need to have 2 tasks running.
Right.
Let's also imagine that in production, we need to give more CPU allocation to those tasks. So what I'll do here is I'll do CPU. Instead of 512, I'll give 1024. And instead of 1024 memory, I might give 2048. So 2 gig of RAM and 1 vCPU. 1,000 in the world of Fargate, 1,000 CPU units comes down to 1 vCPU. So this should allow me to allocate quite a lot more resources to the production environment.
So basically, just to kind of summarize, what we did was we looked at the manifest file which is there for the service, and in that manifest file there is a default value given which is always picked up. But if we want, let's say we have 5 different environments and we want that in 3 of it should be value what is written, so we leave it that way. Wherever we want to override that we will write here in the section as you showed.
Absolutely. So here, for example, I could have my test environment to have one image, or I could, let's say I also have a UAT environment. I can override it here as well.
Yeah,
and that lives in this manifest file that's attached to the service.
Very good.
So let's deploy this and have a look at this in production. So what we want to do now is we want to deploy the service in our production environment to reflect this change to the manifest.
Okay.
So what Copilot's doing here, it's looking at the manifest and it's determining how it differs to the existing setup. And it's updating the CloudFormation then to release the change to the task definition.
All right. And then it will take care of going ahead and updating that particular CloudFormation stack as well, right?
That's absolutely. So that's what we're going to see in the background here is we're going to see a change, an update in process to our CloudFormation stack. Let's see if we can find this one here. It should be.
There is one update which was happening. Yeah, we might have to refresh each and every part of. Yeah, service is getting updated.
That's right. Yeah, the ECS service is getting updated. Let's have a look at the task definition as well, just to see what's in production environment. So we can see here that we've got a task definition for this. We've got a second version of it. And the second version of it has a bit more memory and a bit more CPU.
Yep. And then probably in the service definition, we will see that there should be 2 tasks running. That also we should be able to verify now.
That's true. So let's go to our production. We've got 2 pending tasks and 1 running task.
Right. So desired got updated, which means, yep. And now.
Yep. So the original task, the one that we were running before, is still running. It's waiting for these new tasks to come in. And once these new tasks with more memory and more CPU are created, then the existing task will be removed. And we can see here we're on the second revision of our task definition.
Correct. So like while this is happening, if you see, if someone just looks at the first step, that much difference might not be understandable, I would say. But when you look at this full flow, that you know an application team would be dealing with all these activities day in, day out, right? And of course, multiple environments, as you said in the start. In such cases, doing it via Copilot can be really, really helpful and gives the power or capabilities in hands of developers, actually.
Absolutely.
Yeah. Makes sense.
So this one's just about to come up. So let's have a quick look at these tasks. Okay, we've now got 3 running, which is not what we asked for. We actually asked for 2 to be running. This one will just be spinning down the third one, I should imagine.
Yeah.
And then our release will complete.
Correct.
One thing I wanted to call out while this release is just completing, one of the really, really key things for me for this sort of tooling is to enable secure practices by developers to be followed without needing too much effort. And this is where I think this is one of the really powerful parts of Copilot. This is where we can set up secrets using the AWS Secrets Manager. And we can refer to them in our manifest. And what Copilot can do, Copilot is able to stitch together that secret and inject it when the application starts. So an example here that we've got on the documentation, if we have a secrets manager parameter, GitHub webhook secret, we can set this in our manifest.
Right.
And then once the service starts, for this particular way of doing it, we're then able to have that injected as an environment variable. But we don't need to take the environment variable approach. The application can also use the AWS SDK to pull these secrets from Secrets Manager without having things live in the environment variables.
Right. So that way, any secret value would not be there in any of these files. Rather, it would be there in the Secrets Manager, and during runtime, it gets pulled. Right?
Absolutely. We want to keep the secrets away from source code. So secrets should never live in source code. They should never be checked into a Git repository. We want those to be as close to runtime as we possibly can, so that there's the fewest possible ways of leaking our secrets.
Correct.
Okay, our service is now deployed. So now we can see this one's up in production with quite a lot more resources than our test environment. Cool. So just to close that off, Copilot is an open source tool that's developed by the Amazon ECS team. Copilot helps you to provision your architecture very quickly with good defaults, and it enables you to have a reproducible environment. So you're able to reproduce your architecture across multiple environments. It gives you the ability to control each environment independently, but also to very, very quickly spin up new environments when needed, without the heavy lifting of ClickOps, but also without the verbosity of a CloudFormation template. You can download the Copilot tool from the Copilot website, which you can find on aws.github.io/copilotcli, and get started.
Thank you, Tim. I will leave all the required, these useful URLs which Tim referred. I will put it in the description. Thanks a lot, Tim, for your time today.